Hello everyone. So SRAM has the ability to help you through your full workflow of a steel design, from your analysis to your code checking and your steel sections optimization. So what we have here, it's this steel structure, and we have assigned some section. As you can see, we have different sections for the roof, the columns, and the bracings. We can take a look at the different sections that we selected for this from the European database, as you can see here. And new in SFrames 2025, we have the ability to code check and design these using the Eurocode 3 national annex for Germany. So we have options there, and the first thing that we're going to do is that we're going to run a quick analysis, linear static analysis over here. I'm going to click OK. So now we've completed the analysis. We click on enter. We have a clean analysis, and we can see now that we have some results over here from the different load cases. We can take a look at the reactions if we select a load case, also for the actual forces and the shear forces, some moments, deflections, etc. So once that we've done our structural analysis, we're going to jump into our steel design model. We have two ways. One is by run and steel, or just by clicking here into the build steel design model. So I'm going to click here, and we are taken directly into SSteel's interface, which is very similar to SFrames. So we are going to be taken into this interface where we have different windows. So I'm going to go into the code input window, and the first thing that I want to do is to create code check, to make a code check. So I'm going to select all of my structure to consider all of the members. Then I'm going to go to run, code check, and then I have the option to select the different load cases and combinations. So I'm going to select them all, click on OK, and now it's code checking all of my selected members, right? So we can see here that we have the code utilization for the different members, and the red ones have a higher utilization that we would like to. They are more than 1. So this is not ideal, and some of the columns are passing the code check, and the bracings are also giving us some issues. So first we might want to take a look at why it's not passing. So let's focus on this member over here, and we can go to the code details, and where we are going to be given a detailed explanation and code check of each one of the members. So if I zoom in here, we can see that the governing geometrical slenderness ratio, it's over 1, so that is why it is failing. We have over here the section that we are evaluating. It's an IPE 450. It's given as a section class, and we can see that the rest of the code checks for this load case are doing okay. So we can take a look at the different load cases and load combinations for this section. If we go to the next page, we will see, for example, over here we have the second load case, and we can see that it is also failing in this code check. So we can do this for each one of our members and each one of our sections, right? If we want more information in this about this particular member, we can go to our force diagrams, and we can see the force diagrams for that member in each one of the load cases and combinations, so we know what is happening inside that particular member, right? So we know that this is an IPE 450 sections, and we know that the rest of the roof it's basically failing. So let's go into our design input window, and first thing that I want to do is that I am going to deselect all of my members, and I am going to focus on this member, which is the roof, the member that we were taking a look at, and then I am going to select all of the members in the same design group, right? So I'm going to focus on my roof members, which are the ones that are basically giving us more issues. After that, I can create my sections for study by clicking here in define a subsection for study. So I can change the different section shapes, double angles, channels, hollow sections, but I want to stick with the I or W sections. Now, I can select different section types if I want to. I'm going to go ahead with just the IPE and IPN sections to give it all of the different sizes for that. If I wanted, I could sort through the minimum and maximums for these particular sections, right? So based on mass, and cost, and surface area, that it's up to me how I want to sort these type of sections. I can also take a look at the particular section's properties, for example, the IPA 100A. I can take a look at the section properties and decide if I want to study it or not. So for now, I'm just going to keep considering the IPE and the IPN. After that, I click on OK, and then I go to Run, Design, and once again, I select the load cases and combinations I want these to be run for. Click on OK, and now basically we are running each member to each load case to each one of the selected sections, right? After that, now I can see that my proposed sections, my new sections, are all passing the code checks. We have some that are very well designed with a utilization ratio of 89 or 70%, and we have others that are a little bit over designed over here. So if we take a deeper look at this same member and we go to code details, we are going to get this dialog where I can see the different sections that are admissible. For example, we had an IPE 450, and now the proposed section, it's an IPE 600A. So let's take a look at the code details for that new section. So I select it here and I go to code details, and now I get this report over here. And if you remember, we had a failing code check in the slenderness ratio of over 1. So now it's all the way down to 89%, right? So we can check again all of the different classes and all of the different load cases and combinations. And here we see that the section was 450 and now it's 600A. So we can do this for both the admissible sections that we have. We have here a list, and we can sort it by weight or surface area or depth or whatever criteria that we want. And we can also take a look at all of the inadmissible sections that were compared to. So once that we've done this, we can go back into our analysis model, updating our new sections into the S-ray model for reanalysis.